You ever get that? Like you're just really cranking on a Spark application and bam, out of memory error. Just slams the brakes on everything. Infuriating. So today, we're going to do a deep dive into Spark memory management. Not only understand what's going on, but how to optimize and hopefully prevent those hair-pulling crashes. Our guide for this is a great video from Clever Studies. They did a really good job breaking this down.
Yeah.
So even if you are newer to Spark, this is great info. And if you've been around the block a few times with Spark, I think you'll still find some good nuggets in here.
For sure.
Let's jump in. So Spark, we all know it's distributed, right? We've got our driver, executors, containers.
Yeah. And those each have their own memory requirements. So it's not just about how much memory you allocate to the Spark application overall.
Right.
You know?
It's like packing for a trip. It's not just about everything fitting in the suitcase.
Right.
It's also, can you lift the suitcase?
Yeah.
It's kind of like an overhead memory in Spark.
Yeah. That's a good analogy. And people forget about that overhead, that extra 10% that Spark needs for itself, you know, to do all the things that Spark does. Communicate between driver and executors and manage those containers.
What happens if we forget about it?
Spark gets a little grumpy.
Oh, no.
You start seeing more errors.
Okay, so we've got our driver, our executors, our containers. We've got to remember that overhead. What else?
Well, within each executor, there's another distinction. JVM heap memory versus non-JVM memory.
Okay.
Think of JVM heap as Spark's main workspace.
So that's where all the data, like wrangling, processing, all that's happening in the JVM heap.
Exactly. That's where Spark stores the data that it's actively working on.
Okay.
And then non-JVM memory, think of that as more like the storage room.
Okay.
So Spark will use that for things like storing data structures, maybe some internal bookkeeping information, stuff that doesn't need to be in that main workspace.
Gotcha. So within those executors, let's talk about where all the magic happens. Where's that memory allocated? This is where things start to get interesting.
Right. It's all about optimization, right?
Yeah.
This is where it becomes critical.
So the Clever Studies video does a great job. They've got some visuals to explain this.
Yes.
I'll do my best to kind of paint that picture for our listeners here, but essentially you have three main areas within each executor's JVM heap memory. You've got reserve memory, Spark memory, user memory. Let's break each of those down a bit further, starting with reserved memory.
Reserved memory is super important because it prevents crucial Spark internal operations from being starved for memory, which can lead to all sorts of unpredictable behavior.
So this reserved, is this Spark kind of marking its territory, saying like, this is mine, don't touch it?
Yeah, it's basically like a safety net.
No.
It's generally around 300 millibait and prevents nasty errors that can bring your application to a screeching halt.
So then we're left with the rest of that executor memory.
Right.
Which, by default, there's a 60-40 split between Spark memory and user memory.
And that default ratio, before we forget, can be tweaked based on your needs. So if you have tasks, for example, that involve tons of user-defined functions, you might want to give user memory a larger share of the pie.
Okay.
And you can do that with the help of a handy configuration option, spark.memory.fraction.
I like it. So it's not one size fits all.
Yep.
No can adjust as needed.
Exactly.
Okay, let's dig into those two memory hogs then. First, Spark memory. So this is memory that Spark itself uses for all of its operations.
Yeah, so think of this as the engine room, right? Where Spark stores data for processing, caches results for faster access, and of course shuffles data between those busy executors.
So you busy.
Always working.
We're not done yet, though. So even within that 60% chunk of Spark memory, there are two more players. We've got the storage memory pool and the executor memory pool.
You got it. And this is where things get really interesting, because these two memory pools can actually share memory dynamically. Imagine them as friends who can borrow money from each other when needed.
Okay, I'm intrigued. Tell me more about this.
Yeah.
What makes this friendship so unique? And what happens when things go wrong?
So the storage memory pool, that's the friend who's always prepared. They love to keep things cached, data that they think you might need later. So this pool stores frequently accessed data sets in memory. So Spark doesn't have to go searching for it every time.
Okay.
Speed and efficiency.
So it's like having your, I don't know, like your favorite snacks
Right.
within arm's reach.
Right.
I don't have to go like digging in the pantry every time I want some M&Ms.
Exactly. And then the executor memory pool, that's the friend that's ready to roll up their sleeves and get things done. So this pool is what provides the memory necessary for Spark to actually execute those tasks, the transformations, actions, everything that you define in your conduct.
All right, I like it. So storage is like the preparation, executor is the action hero.
Exactly. And here's where the friendship comes in. So if one of the pools is running low on memory, it can actually borrow from the other, as long as it's within a certain limit. Right. So it's a really cool system that allows Spark to be dynamic, adapt to different workloads, use memory efficiently.
Yeah, that's a real friendship. Always willing to lend a hand, or in this case, lend some megabytes. But like any good friendship, things can get a little complicated.
Oh, yeah.
Right.
Absolutely.
Give me an example.
Yeah. So, for example, if the storage memory pool, borrows too much from that executor memory pool, and the executor memory pool needs it back to, process a task, that's where we run into problems.
Uh-oh. Is this where we get those dreaded out-of-memory errors?
This is exactly how we get those. So it's kind of like, I don't know, when you lend your friends some money and then they forget to pay you back, everything's fine until you actually need that cash.
Right.
Yeah.
And then suddenly, the friendship is tested. So how can we, as Spark developers, how can we prevent those memory pools from having a falling out? How do we troubleshoot? Let's talk about those out-of-memory errors.
Well, remember all those different components that we talked about?
Yeah.
Understanding each of those is going to be critical for becoming a Spark memory detective.
Okay. I like it.
So let's start with that, that first potential culprit overhead memory.
Okay. That extra 10% Spark needs for all the backstage things that it's doing.
Exactly. And if you haven't factored that in when allocating resources, it's like trying to cram one too many items into an already full soup case.
Yeah.
Something's got to give.
Right. So we need to make sure we're giving it some breathing room.
Yes. Always double check those calculations.
Okay.
All right, let's move on to our next suspect, the storage memory pool.
Okay, the one that loves to cache.
Yeah.
What could go wrong there?
What could go wrong? Well, when you're so excited about a trip, you pack your entire wardrobe, even though you're only going for the weekend.
Yeah.
That's kind of like overusing caching in Spark.
Okay.
You get excited about, oh, I can cache all these things, but you have to be strategic about it.
Right. So ask ourselves, is this something that's going to be accessed frequently enough to justify me using that space up?
Exactly. Ask yourself, is this data truly accessed frequently enough to justify storing it in memory? If not, you're just taking up valuable space that could be used for other tasks.
And I'm guessing if we overcache, that's going to cause a bottleneck and maybe lead to those out-of-memory errors.
Got it. Now let's move on to our next suspect, the executor memory pool, the one that's always working hard, executing tasks.
And that's the one that could potentially be lending out to storage.
That's right.
Which is good. But also, we got to be careful.
It's all about balance.
Yes.
So if that executor memory pool lends out too much and needs it back, you're going to run into trouble.
Delicate dance.
Yeah.
What about user memory? Could that be a culprit in our little memory mystery here?
Absolutely. This is where your code comes into play.
Okay. So if we're not careful about how we're actually writing our Spark applications, that could be a source of memory issues.
Imagine you have a limited amount of desk space, right?
Yeah.
And you just start piling on papers and books and coffee mugs.
Oh, no. My desk is a mess.
Eventually, you're not going to have any room left to do work.
I see where you're going with this.
Right. It's the same with user memory. If you're creating these massive objects in your Spark code or using inefficient data structures, you're essentially taking up valuable space in user memory that could be used for other tasks.
So it's not just about how much memory we allocate to Spark, it's how we're using it within our applications as well.
Exactly. It's about the big picture and those smaller details.
Okay, so we've covered overhead memory, the storage memory pool, the executor memory pool, user memory. Anything else we've got to be wary of?
Well, there's one more thing. Remember that minimum executor memory requirement we touched on?
Right.
Spark is very particular about this one.
Spark's got its boundaries.
It does.
It's like, hey, I'll share, but there are some rules.
Exactly.
This is my side of the room.
So Spark needs a certain amount of memory just to function properly, and it's not afraid to remind you if you're not providing enough. Remember that reserved memory, that 300 millibaud that Spark keeps for itself. Well, there's a rule. The total executor memory you allocate must be at least 1.5 times the size of that reserved memory.
Okay, so if we don't follow this rule, what happens?
Let's just say Spark won't hesitate to throw an error message your way, bringing your application to a grinding halt. It's a friendly reminder that even though Spark is powerful and flexible, it still needs those essential resources to function correctly.
It's like, this is my line, don't cross it.
Exactly.
Yeah.
Gotta have those boundaries for everything to run smoothly.
Okay, well, I think we've covered a lot of ground here.
Yeah.
We talked about those memory-hungry executors, about respecting Spark's personal space,
It's important.
and all those little details, right? I mean, they seem small, but they can make or break your application.
Oh, absolutely. It really is. Like tuning a high-performance engine, you know? Even the slightest miscalculation can have a huge impact.
Yeah, for sure. Now, before we wrap up, I want to go back to something we mentioned earlier. Data partitioning. Where does that fit into this whole memory management puzzle?
Oh, yeah. Data partitioning. Huge topic.
Yeah.
We could do a whole nother deep dive on that one.
Yeah, maybe we should.
But essentially, it's all about how you're distributing your data across those worker nodes in your Spark cluster.
So instead of treating it like this big giant thing, we're dividing and conquering, right? Breaking it down into smaller pieces.
Exactly. Smaller, more manageable chunks. And that can have a big impact on memory and performance.
Makes sense.
Think of it this way. Like, imagine trying to fit a giant pizza into a small oven.
Oh, no. Disaster.
Not going to turn out well. Burn crust, gooey mess. But you cut that pizza into smaller slices.
Okay, yeah.
Bakes evenly, efficiently.
So by partitioning our data, we're basically helping Spark digest and process everything without, like, choking.
Exactly, you got it. When your data is partitioned well, each executor only has a small piece of the pie to worry about. Less pressure, less memory needed.
Okay, that makes a lot of sense. So it's all about making sure that each executor has what it needs, can do its job, without throwing a memory tantrum.
Right. And speaking of optimizing, don't forget about serialization, another key player in Spark memory management.
Oh, right. Serialization. Refresh my memory. What was that again?
Okay, so basically serialization is how we transform your data into a format that can be easily stored, moved around the network, like packing a suitcase. We want everything nice and organized, right?
Okay, yeah. Efficient packing.
Exactly. So the way you choose to pack or serialize your data, it impacts how much memory your Spark applications use.
Makes sense. Different packing methods, different space requirements.
Exactly. Spark supports a bunch of different serialization formats. Some are faster, some are more compact, some use less memory. Picking the right one, it's like choosing the right suitcase, right?
Okay, I like that analogy. So a small duffel bag for a weekend trip. But for that big, long vacation, we're going to need something bigger.
Exactly. The point is, there's no magic bullet. Optimizing Spark memory management, it's not just about tweaking a few settings. It's about seeing the bigger picture, understanding how things work together, your data partitioning, serialization, how efficient your code is, how you're allocating those precious resources.
It's a lot to think about. But it sounds like if you take the time to really understand all the moving parts, it can make a huge difference.
Absolutely. And remember, learning never stops. Spark's a deep ocean. The more you explore, the more you'll discover new challenges, new ways to optimize. It's a journey.
That's a good way to put it, a journey. Well, I think that's about all the time we have for today's deep dive. To our listeners, keep those memory management principles in mind. And don't be afraid to experiment, optimize, learn. We'll catch you next time.